This is Lauren, Myles, and Ellie and Carwynn's project, Glasses.
The problem we want to address with this project is how deaf students lack independence within the classroom due to their reliance on interpreters, and how modern classrooms are not designed to accommodate people with disabilities. And this can provide many challenges for people that are deaf or hard of hearing, especially within the school environment. Deaf/slash hard of hearing students would need an interpreter to be able to understand what the teacher or their classmates were saying. Some students may be able to read lips, but only when the teacher or student is facing them. If they're writing on the whiteboard while speaking, for example, the deaf student would not be able to understand what was going on because they wouldn't be able to see the teacher's face. One accommodation has been to put students in completely separate classes from their peers, but this isolates the student and does not allow them to engage with their classmates, which can be emotionally and mentally stunting for growing children.
Our solution is glasses, which is basically smart glasses similar to Google Glass and other existing technologies, except we are going to leverage those technologies and improve on them to create embedded displays with live closed captioning for those students and other individuals that are hard of hearing. Some of the challenges that we seek in this endeavor is that battery life is going to be a big problem. We need it to be able to last all day, while also we need it to be fast and accurate. We need to be able to get this to work in crowded areas once we're able to go back into those crowded areas.
For the need and market, we looked at the current and expected growth for wearable tech and noticed the overall greater exponential growth compared to other products for eyewear and headwear in lavender. With this growth, we needed to make an effort to be inclusive and to the deaf and hard of hearing community in the future for this industry. Our solution would impact or help our target population of the 62,000 approximated students in pre-K through grade 12 who are typically isolated in classroom settings. This tech could expand to these 600,000 deaf and hard of hearing individuals in the US and all deaf individuals worldwide, contribute to improved communication between deaf and able individuals, and even help those who communicate with different languages, including verbal language and sign language, of which there are between 100 and 300,000 variations.
We would like to create these glasses to address the engineering grand challenge of advancing personalized learning. These glasses would allow students the ability to have some independence within their lives and be able to interact without an interpreter in their day-to-day lives at school and in the world.
How might our idea help the target population? We hope to offer alternatives to already existing accommodations. We hope that we'll be able to add glasses to existing IEPs and 504s to help in the classroom and in other environments. We also want to normalize deaf students in the classroom in order to reduce social anxiety, but also improve communication between them and their peers.
One piece of technology that would be useful to leverage is the Google Glass. Google Glass acts as a hands-free smartphone that can display images and information on the screen of the glasses. Users are able to access the internet, camera, maps, calendar, and other apps by voice commands. Georgia Tech created an app that pairs with the Google Glass, in which the speaker talks into the app and the app sends the translated speech to the Google Glass display to be read by the person wearing the glasses. Another piece of technology that we would improve our product is the shotgun microphone, and it is a highly directional microphone that is pointed directly at its target for accurate recording. The concept of a directional microphone would help solve the problem of interference from opposing noises. The glasses must be designed to differentiate between voices. Well-known and highly personable tech such as Siri, Amazon's Alexa, or Google Home use voice recognition systems that are able to differentiate between background noise and the speaker. The glasses would need to have a system that operates by voice recognition. In order for the glasses to create a live stream of text, there would need to be an automatic speech recognition system, in other words, a speech to text system.